All right, guys, here's my last example, 7.3 example 3. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis. So let's see what this sketch is going to look like. So first, x squared plus 1 is a quadratic opening up through 1. Y equals 0, x equals 0, and x equals 1. So we're looking for this shape rotated about the y-axis. So that's great. This is my half. Here's my shape. So it's basically like a cylinder with a bowl cut out the top. So remember, if I wanted to do discs, it would be okay up into this point, and then I would have to do washers from this point. That's a little too much work. So let's try a shell. So here, if I draw this Riemann sum, it'll be the same Riemann sum no matter where I draw it. And there's my shell, dx. And remember, I'll do infinitely many of those Riemann sum shells. So volume equals 2 pi RH times thickness. My thickness is dx, which lets me know this should be in terms of x. Volume equals 2 pi integral from 0 to 1 of my radius, which is x, times my height, which is x squared plus 1, times my thickness, dx. So volume equals 2 pi integral from 0 to 1 of x cubed plus x dx. Volume equals 2 pi x to the 4th over 4 plus x squared over 2 from 0 to 1. Volume equals 2 pi 1/4 plus 1/2. 2 pi multiplied by 1 plus 2, 3/4. That is 3 pi over 2 units cubed. So remember, I could have tried to do a disc and then a washer, but that's way too much work. Cylindrical shells are shortcuts. So we'll practice these in class tomorrow.